This is an artistic point of view of how neutron stars collide, where their core is so dense, so hot, and they're so small, but they're packing a lot of mass, that their core is made up of primarily neutrons. And what this means is there are positively charged protons, negatively charged electrons, which combine into uncharged neutrons. Similar to white dwarfs, neutron stars are the leftover remnants of a dead star. But the big difference is neutron stars form from the death of a massive star, which core was left over and formed the neutron star. A white dwarf is a leftover core of a smaller mass star that died. And there was a recent study done out of the Department of Energy and Los Alamos NL Laboratory that's looking at how heavier elements may have formed in the universe and more heavy elements that we might not have even detected yet. Now, most of the heavy elements we have today formed from stars, from fusion happening in its core. Most of the more abundant elements in the universe that really existed for, billions of years, millions of years after the Big Bang were hydrogen and helium. Very abundant, very common, very just light as well. I mean, you look at the periodic table, hydrogen and helium are like the first two. But what about iron? What about heavier elements? Most of those form through stars in their core, fusion, but then also when stars die, they emit a lot of their elements, a lot of energy. But there was this recent study saying that there might actually be heavier elements than what we already have on the periodic table of elements that we just haven't discovered yet. And those elements may have formed from neutron star collisions. Now, this study is going to be looking at something known as nuclear fission rather than fusion, which fusion is, the fusing of two atoms together to form new atoms. This is the splitting of atoms, potentially heavier nuclei of elements that might be present somewhere in the universe that we just haven't discovered yet, which completely blows my mind to really think about. I'm looking at like a little write-up I did for my astronomy class about this, and it just kind of blows my mind to think about. And especially they said that they found signatures or signs of nuclear fission being present within elements of older stars, which could imply that heavier nuclei elements are present. Heavier than what's on the periodic table. And that's just really interesting to think about. Kind of crazy thing too in this article is it talks about how since 1992 there's been limits on testing of nuclear weapons, and this has to do with nuclear fission. And so a lot of experimental data on nuclear fission has been pretty limited and cut back. And so kind of studying something like this, even if it has to do with stars, is highly monitored because of the implications and the use for weapons of mass destruction. Yeah, so anyway, I thought this was a pretty interesting research study. I just love things on neutron stars, pulsars, spinning neutron stars, colliding neutron stars, all that stuff, supernovae, explosions, all that fun jazz. So let me know what you think.